Hello everyone, most welcome to the Gate Academy YouTube channel. Today here we are having very interesting quiz from the subject Thermodynamics, which will be live quiz. So you can join along with your friends. I'll tell you how to join. The link is given here definitely. So let us begin the quiz for the subject Thermodynamics, which will be of 30 minutes. Instructions. So it's very important to know how to play the quiz. So first of all, it is very important how to join. So you can see here to join the quiz, we are having here the link given bit.ly/tga076e, right? You can see on the top of the page. And you need to have two devices to play this quiz, because in one device you can see the YouTube channel, and in one device you can play the quiz. And if you are having only one device, like one laptop you are having, so you can open two tabs. In one tab you can see the YouTube channel for this quiz, and in another tab you can use your screen for the playing this quiz, correct? And in mobile, if you are having, you can also use your split feature of the Android. So by this, two screen can be seen in one device. And what are the important instructions for playing this quiz? I will tell you all about the quiz. So the total timing will be 30 minutes. So we will be having near about 5 to 6 questions. And for every question, there will be given frame of time. And there are some points given to each and every question. So within the given frame of time, if you are answering correctly, you will get the points. And after that, leaderboard will be generated. So all the questions will come in sequence one after another. Once all the questions will be finished, leaderboard will be generated. Who is the winner? All things will be displayed. Then after that, I will solve all the questions for the quiz, starting from the given data to the last answer value received with the proper units. And in case if you are having any doubt, definitely you can ask me anytime. So if you want to join, you can also see the link is given in the YouTube channel. On the chat box, you can see the link is given. You can use the link to play the quiz. Okay. So how to play the quiz? There are some more information about this quiz I want to tell you. So there will be no negative points here for the quiz. That means you are free to attempt all the questions because there is no negative point. So no risk at all. Number of points will be definitely mentioned for each question. On the top of the page you can see. And what is the type of question, like whether the question is of numerical answer type, or this is a multiple choice question or multiple selection question. All this detail will be mentioned in the top of the page for each and every question, which will be coming in the sequence. So if the question is tough, we will definitely start with the easier question, level 1 question. And as we are proceeding further, the level of question may become tough. And if you are attempting the tough question, then you are eligible for getting more points. So tougher the question, higher the points for you. And faster you answer. Definitely the time is very important in the GATE examination. You know that for each and every question, we have to plan that how much time we need to give. So if you are going to give the answer earliest, you are going to get more points. So your score will be higher. Okay. Next. So here I'm waiting for the players to join. Using the link, you can join the quiz here, bit.ly/tga076e, right? So Sai Sridhar, very good evening. How are you, Sridhar? From where you are? Which place you belong to? Shreyas, most welcome. Most welcome to the live quiz for the subject thermodynamics. And today we are going to take a very important topic, that is pure substance. which will be the basic of the fundamentals for the Rankine cycle, or you can say the vapor power cycle. Sridhar, most welcome. You have joined, and you can also send this invitation link to your friends and tell them to join this live quiz webinar. It is also given in the chat box in the YouTube channel, and also you can see on the top of the page bit.ly/tga076c. Okay. So Shreyas Gandhi, you are from which place? Yeah, I can see your chat box. You can reply definitely. You can type the message. Okay, Pune, very nice. So you can tell your friends to join with the given link. So more number of people are there, then more interest, right, will be there in the quiz. When participants are more, any program or any quiz, any game will become more interesting. Mohammad Sadaf, most welcome to the Gate Academy YouTube channel. So today we are having this quiz for the subject thermodynamics from the topic pure substance. And like this, we'll be continue to conducting the quizzes for the other important topics in the subject thermodynamics. Okay, so now I'm going to the next page. You can send this link to your friends, tell them to join. You will feel very interesting here to play the quiz. So this is here question 1 of 6. So there are 6 questions. So this is the first question you can see on the screen, which is of multiple choice question of 60 seconds is the time given allotted for this question. A rigid container of volume 0.5 meter cube contains 1 kg of water at 120 degrees centigrade. A specific volume is given, VF and VG is given. You have to find what will be the state of water. Like state of water means whether it is a compressed liquid, saturated vapor, saturated liquid, or a mixture of saturated liquid and vapor. So you can solve this question also like a numerical, or by looking into the data also you can understand what will be the exact condition of water. Okay, so one question, one person has given the right answer, I can see here. So let's go to the leaderboard, and yes, Sridhar, you have given the right answer. Very nice. Shubhadeep and Shreyas, you can try for the next question definitely. Okay. So you can see the next question which is coming on the screen. Question 2 of 6. The correct statements about the characteristic of a critical point of a pure substance is that. It's a multiple selection question. You can see MSQ, right? So which are the correct statements? It may be 1, it may be 2, it may be 3, it may be all 4. So read the options very carefully and do understand what is the definition of critical point, and accordingly you can choose the options. So important points are definitely there for the critical point during when we understand the definition of critical point. So these all points will be there in the mind. And we can also represent the critical point on the TS diagram in the vapor dome. for the pure substance. Okay, so only 10 minutes, 10 seconds are remaining. Please give the answers. Yeah, the time is over now. Yes, I can see correct answer. Yeah. So there are 3 correct options. You can see here, there is no constant temperature vaporization process. It has a point of inflection with 0 slope, and saturated liquid and saturated vapor states are identical, right? So one person has given the right answer for this, and you have chosen. So you have to tick all the points. Okay. Let's go to the leaderboard. So the points is same here because none of you have given the right answer. That means none of you have chosen all the correct 3 options. Okay. So let's go to the next one. Another easy question is there. Question 3 of 6. Yeah, this is just based on the equation, one of the most important equation for the pure substance. Multiple choice question. Which one of the following equation is correct? I hope all of you can give correct answer for this question. Which one of the following equation is correct? Only one correct answer is there. So X is here dryness fraction. X is here dryness fraction. And Vf and Vg is given. And V is your specific volume. What is the correct relation? How we can find the volume at any point when X is given, dryness fraction is given? So 10 seconds are remaining. Please mark your answers. Yeah. So 0. Yeah, none of you have given the right answer. 2 of you have chosen this C, which is wrong actually. So don't worry, I will tell you which option is correct and why this is the right answer. Okay, I'll explain you everything from the beginning, from the basic. Next. So still the points remains the same as you have not given the right answer. So still more questions are there. We can try again. Yeah. Question 4 of 6. Which of the following are pure substances? So what are the examples of pure substances? If examples are there in your mind for the pure substance, you can choose the correct answer. Gaseous air, a mixture of gaseous air and liquid water, a mixture of liquid water and water vapor, a mixture of gaseous air and air, right? So here you can see 2 statements are correct, either P and Q, Q and R and S, and P and R, right? So one option we have to pick from these 4 options. Sufficient time is given for this question, right? Please think before marking your answer. It should be there in the mind. What is your liquid water and what is the definition of pure substance? That is very important here to choose the correct option. Okay, so time is over almost. So P and R, very good. 2% have given the right answer. Very happy to see this. So let's go to the leaderboard. Yes, Suhadeep, very good. You have given the right answer. And Sridhar. So you have also given the right answer. Shreyas Gandhi, you can try still. We have 2 more questions. Okay. Second last question. Fastest answer will get the more points. On PVT, pressure, volume, temperature, surface. That is the curve on this graph PVT. The triple point and the critical point are seen respectively as. How you're going to see these points on this PVT surface as a line? Both points are a line, or one is line, one is point line, or point. Okay. So I'm also having the diagram, 3-dimensional diagram. I will show you this PVT surface. Then you will understand. If you are knowing this, very good, you can directly find out the correct option and you can mark your answer here. Don't forget to mark your answer. Yeah, one person given the right answer, line and point. That's correct. I think one person is not able to have not marked the answer, right? Let's go to the leaderboard. Yes, Subhadeep. Okay, so you can see you came on the top of the page now, right? So very nice. Sridhar, you have marked the wrong answer for this. Shreyas Gandhi, I hope you are not answering, right? Let's go to the last question. Yeah, more point for the fastest answer. The enthalpy of evaporation for a pure substance increases with. All the questions are theoretical questions and easy question, level 1 question. The enthalpy of evaporation, that is written as HFG, right? For a pure substance increases with. So this value, HFG value, how it will increase or decrease, right? That is very important here. Yeah. So 10 seconds are remaining almost. You can mark your answer. Yeah, one person is given the right answer, decreasing temperature. That's correct. So let's go to the leaderboard. So final answer is here. You can see final results. Subhadeep, you got the highest point. Very nice. And you won the quiz. Definitely, right? Yes. So yeah, now what we can do, we are going to see the correct answers and solution also, if it is required, why this answer is right, correct, for the all the questions which appeared in the quiz. Okay. So I'm switching the page. Yes. So I hope the new page is visible to you. So Madhav, can you see here? Sridhar, are you there? Please reply. Yeah. So let's go to the first question here. A rigid container of volume 0.5 meter cube, right, contains 1.0 kg of water at 120 degrees centigrade, correct? So let me just write down the given data. Yeah. So let me just write down the given data here. So what is given here? V, rigid container of volume, right? Total volume is given. V is equal to 0.5 meter cube. Okay. Contains 1 kg of water. Very important information is given. Mass is 1 kg at 120 degrees centigrade. I'll write that also. So VF is mentioned here, and Vg is given here. What is the state of water? Very important to note this Vf and Vg value, right? What is the state of water? So you must be knowing that we have formula for enthalpy. When you know the dryness fraction, what is the formula for enthalpy? H is equal to Hf plus X into Hfg. This formula is also applicable to entropy. S is equal to Sf plus X into Sfg. Not only enthalpy and entropy, you can also apply this formula for the volume. A specific volume V is equal to Vf plus X into Vfg. And what is Vfg? Vfg is Vg minus Vf. So we are going to make use of this equation to find out the value of X, dryness fraction. Once the dryness fraction is calculated, you will be knowing the exact state of water, correct? So what is dryness fraction? Let us now put the value here. So 0.5, right? V is your 0.5. How V is 0.5? Specific volume is equal to volume per unit mass. Okay. So volume is 0.5, mass is 1. So it is 0.5 meter cube per kg, right? I'm getting the exact unit also, you can see. So 0.5 is equal to Vf. Vf is given in the question 0.00106 meter cube per kg, right? Plus X into what I will do now, Vfg. Vfg is Vg minus Vf, right? So Vg is your 0.8908. 8908 minus is your Vf 0.00106, right? Correct. So you can do this calculation. Yes, you can do this calculation, Sridhar, and you can find out the value of X. From this calculation, X is coming out 0.5607, right? Value of X. Dryness fraction has no unit. 0.5. 0.5 means it is inside the vapor dome, right? We know this diagram, right? TS diagram. Let us say I am drawing the TS diagram here. This is the vapor dome, right? Vapor dome. And this is the constant pressure line drawn in the vapor dome. So this is your critical point, and these are dryness fraction lines, correct? So 0.5 means the line is here, 0.5. X equal to 1 here, and X equal to 0 here on this line, correct? So 0.5 means it is inside the vapor dome. So the state of water is a mixture of saturated liquid and saturated vapor, right? Understood? Any doubt here? You can ask me, Sridhar. Very good. Thank you for giving the correct answer. The value of X 0.56. Okay. Let's go to the next question. Yeah. The correct statement about the characteristics of a critical point. Okay. Critical point. So what is critical point? Let us understand here from this diagram. Okay. Let us say I'm drawing another pressure line here, constant pressure line, right? So let us say this is 1 bar and this one is your 2 bar. Okay. Example. So if the red line is your 1 bar and this is 2 bar line. So what happens when you increase the pressure, correct? When you increase the pressure, your saturation temperature Tsat also increases. When you increase the pressure, your Tsat also increases. For example, water starts boiling at 100 degrees centigrade, but at 1 atmospheric pressure or 1 bar. So at 1 bar, the saturation temperature is 100 degrees centigrade. But if you increase the pressure, let us say 1 bar to 1.2 bar. So if the pressure is 1.2 bar, then your boiling point will not be 100. It will be more than 100, like 120, 115 degrees centigrade, right? So higher the pressure, higher the saturation temperature. So if you keep on increasing the pressure line, saturation pressure, so Tsat value will keep on increasing. So, but what happens to this distance HFG? So this is your F point, this is G point, right? So the enthalpy of evaporation, HFG, this is the HFG value. So if you increase the pressure, correct, the enthalpy of evaporation decreases, and it becomes 0 at a point. This point is called as critical point, right? This point is called as critical point, where your enthalpy of evaporation is 0. And if the pressure increases, your saturation temperature increases and HFG value decreases. This is very important. Now you can see. So correct statement about the critical point is there is no constant temperature vaporization process. That's correct. There is no constant temperature vaporization process because during the phase change, the temperature remains constant. So it becomes like a point. So there is no distance available here, no HFG. So there is no constant temperature vaporization process. Plus correct statement. It has a point of inflection with 0 slope. On the top of the dome, you can see the slope is 0. Point of inflection also means where the slope changes. So you can see this on this side, if you're coming, it is a saturated liquid line. On this side, we are having a saturated vapor line. Correct. So second point is also correct. The ice directly converts from solid phase to vapor phase. This is wrong. Can anyone tell me why this is wrong? C point is wrong. Why? Why C point is wrong? Anyone? You can type the message. I'm waiting for your response. The ice directly converts from solid phase to vapor phase. Yeah, now look at the answer. On this side, left side of the saturated liquid line, we are having the liquid only, compressed liquid here, right? And this is superheated vapor. So it is not the ice converting into vapor. It is the water only converting directly into vapor. It's not this portion is not for the solid ice, right? It is water only. Water directly changes into vapor without going through the vaporization phase. Okay, so that's why C point is wrong. And D, saturated liquid and saturated vapor states are identical. So we are having the same point. We are having the same point for the saturated liquid and saturated vapor here. You can see from here only it divides. So at this point, we can say both exist. So A, B, D are the correct answer for this MSQ. Next question is here. Multiple choice question. Which of the following equation is correct? Already we mentioned here, right? You can see the three equations I mentioned here. So VF equal to VF plus X into VFG. So let us go and see what is mentioned in the first option A. When you write V is equal to 1 minus X. So just open the bracket. What we are getting? VF minus X VF plus X into VG. So we can definitely write our correct equation is V is equal to VF plus X into VFG, or you can write V is equal to VF plus X into VG minus of VF. Okay, this is the correct equation. So definitely it is same. You can see VF plus X, you can write this VG, you can put it here, X common out, so minus VF. So we are exactly getting the same answer as per the equation. So this A option is correct. B is wrong. This is also wrong. Not applicable, not applicable, right? So this is the correct answer. This is also applicable to entropy, enthalpy also. Correct? That we have seen here. You can see all three equations I have written. Now, which of the following are pure substance? Right? Which of the following are pure substance? So pure substance means, what is the definition of pure substance? A pure substance is defined as one that is homogeneous and invariable in composition throughout its mass. What is the meaning of this line? I'll tell you. For example, we are having water. So if you take water from the well, river, ocean, tap, lake, anywhere, it will be having 2 molecules of hydrogen and 1 molecule of oxygen, H2O. Correct? H2O. So, and also the mass distribution is homogeneous and invariable in composition throughout its mass, H2O. Everywhere there will be 2 hydrogen and 1 molecule. So gaseous air is definitely having the same composition. So whether you are in Pune, you are in Delhi, Bombay, Chennai, Bangalore, Hyderabad, any place, what is the composition of air? We'll be having the nitrogen, we'll be having the oxygen, carbon dioxide, inert gases, and water vapor. These are the components of air. So this all will be present everywhere, correct? So gaseous air is also a good example of pure substance. A mixture of gaseous air and liquid water. No, water is having different components like hydrogen and oxygen, and air is having different. So this is not a pure substance. Then a mixture of liquid water and water vapor. Yes, whether the water is in liquid state or in vapor state, the composition will remain same. So this is correct. P and R option is correct. A mixture of gaseous, air, and oil. No, oil is different and air is different. So this can't be the pure substance. So this is wrong. Okay, so P and R is the right correct statement. So option A is not correct. R and S not correct. Not correct. P and R. Okay, understood. Next one. For MCQ, this one, on a PVT surface, the triple point and the critical point are seen respectively as, right? As I told you, for this, I will definitely show you the 3D surface for the pressure, volume, and temperature diagram. I'm going to show you. Then you can find out for the triple point and critical point. So critical point we have seen just now. What is triple point? Where the liquid water, ice, or water vapor exists in the equilibrium. That point is called as triple point. Well, 3 states of water we can see. That is called as triple point. So now we are going to see the triple point and critical point on the PVT surface. Then after that, you can say which option is correct. Okay. Already we know the answer. Let us go and verify. Okay. I'm just going to show you the PVT surface. Okay. So this is the, you can see the PVT surface here. Pressure, volume, and this is the temperature line. You can see critical temperature, right? Okay. So on PVT surface, you can see here, critical state is here. So critical point looks like a point only, right? This is the point. But you can see here, triple state is looking like a line here, where you can see solid and vapor here. Solid is here, liquid is here, and vapor is here, right? So this line you can see here, triple state line, right? So the triple point appears like a line here on the PVT surface, and critical point is a point, correct? So that is the answer here. Yeah. Okay, I think it is not appeared on the screen. Diagram not represented. Yes, yes. Okay, let me try once again. Let me try once again. No problem. Let me try once again. I think now it's visible. Please check. Yeah, thanks, Sumer, for the information. Yeah, now it is visible, right? Correct, no? Yeah. So yeah, so you can see here on the screen, solid, liquid, and PVT surface, pressure, volume, and temperature. You can see this is critical temperature line, right? Yeah. So critical point is, you can see in this PVT surface 3-dimensional diagram is looking like a point only. You can see this is a point, critical state, and triple point is looking like a line here, triple state line. You can see where you can see this part is solid and vapor. Solid is here, and liquid is here. Solid, liquid, and vapor, all 3 exist here. Solid, liquid, and gas side. So this is a triple state. So it's a line here on the PVT surface, and critical state is a point. Okay. Yes. Coming back to the same page. Okay. So which option is correct? Triple point we have seen as a line and critical point as a point. Okay, fine. So B is the right answer. Last question. Very important and easy question. The enthalpy of evaporation. So how to write this enthalpy of evaporation? It is HFG. Correct? And HFG is equal to Hg minus of Hf. Correct? What is the unit, sir? Unit will be joule or kilojoule per kg. Enthalpy of evaporation for a pure substance increases with, correct? Increases with decreasing temperature, right? Decreasing temperature. So if you come down, right, you can see this diagram. If you come down, your enthalpy of evaporation keeps on decreasing. And if you still come for a lower pressure, your enthalpy of evaporation, this one is the highest, HFG. This is your HFG. Okay. So thank you all. So we have seen almost all the questions for the quiz, and we have seen the reason for why it is correct. So again, we'll see the next topic, that is for the another important topic from the subject thermodynamics. So we'll meet in the next session for the thermodynamics live quiz webinar. So thank you all.